Hello everyone, it's Mr. Rops here, and we are asked to find the roots to this equation. The roots is the same thing as finding an x-intercept, or finding the zeros, or if I just said solve the equation. They're all the same question, just written differently. So we're asked to find the roots of this particular equation, 2x squared equals 13x minus 15. And we could do it graphically two different ways. So let me make my graph here. And in order, the first way I'm going to show you is if I make this y1 and this y2, I make them equal to each other, and I'm looking, and if I graph them, I get this scenario here. And I see that there's a quadratic equation, which is the blue one here, and the black is a straight line, which this is y equals mx plus b. And when I have this, when I have an x squared, I should expect to have two answers. From the graph here, I can only see one. But if I look up here further, and if I zoom, I can see that there is another one here and here. And so there are indeed two solutions, 1.5 and 5. And so from doing this graph here, I can see this graph, and I can see this line here. This is 1.5, and this is 5. So x is equal to 1.5, or x is equal to 5. And those are my two solutions. Because it's x squared, I get this parabola or quadratic graph and a straight line on the other side, so they intersect twice. The other graphing method, what I can do, and this also leads me to the algebraic method, is if I make one side of the equation equal to 0. And that's a key. I want to equal 0. This is true for the second graphing method. It's also true for the polysimultaneous idea. So I'm going to take this and make it equal to 0, which will mean 2x squared minus 13x plus 15 is equal to 0. This is the equation I'm going to graph down here. And so when I graph that, if I turn these ones off, I graph it, the red graph, and I can see there are two x-intercepts, 1.5 and 5. And so when I graph it, I get this equation. This is 1.5, and this is 5. So x is equal to 1.5, and x is equal to 5. I should, and I forgot to do it here, I should label this as y is equals 2x squared minus, undo that, minus 13x plus 15. This one I should say y is equal to 2x squared, and y is equal to 13x minus 15. So I should label what I've graphed. And as you can see, both of these graphs produce the same solution. So either way are okay. Algebraically, if I want to do this method, well, my leading coefficient is 2. The a value is 2. So I do have to factor it, but I'm going to have to do the big giant process of the x in the box. And so I get my x, I multiply 2 and 15 together to get me 30x squared and negative 13x. And what two numbers multiply to get 30 and add to get negative 15? And this is a positive 30 and a negative 13. Well, if I think about that, it's going to be a negative 10x and a negative 3. They multiply to get positive 30, and they add to get negative 13. Then I go and I move to the box. I put my values in the box. This is 2x squared goes here. 15 goes in the bottom. And then negative 13x goes in these two, and they go in the form of negative 10x and negative 3x. And now it's about pulling out my factors. Between these two, I have a factor of negative, because this is the boss, 5 between those two. Here, I get an x. Going here, I get a 2 x, and going here, I get a negative 3. Putting it all together, then it factors to 2x minus 3, parenthesis, x minus 5 is equal to 0. I factor this to this scenario. Once it's there, then the null factor law applies because there's a product. It's this number times this number. What makes them 0? Well, 2x minus 3 is 0, or x minus 5 is 0. Well, that's x is equal to 5. This is 2x is equal to 3. If I add the 3, divide by 2, and I get x is equal to 3 over 2. And so here are my answers for x algebraically by factoring, which is the same as 1.5 and 5, 1.5 and 5, 1.5 and 5. It all is consistent. The last one I'm going to do is polysimultaneous. The only thinking involved with this is going, oh, the easiest way to do it is with my calculator, I think. So I go apps. I hit polysimultaneous. Enter. Poly root finder number 1. I go to next. My coefficient is 2, negative 13, and positive 15. Enter it. Ask to solve it. And again, from here, I can see that I get x is 5 and x is 1.5. 4 different ways to do the same question. And it's important that you recognize that they're all equally valid representations. This is the algebraic approach, which if you don't have a calculator, is really the only approach you have available to you at this point. Good luck.